Open source is usable with any other software, even if that other software is not open source software. This is the 9th point in the open source definition. It means that we get a lot of flexibility when we develop our code in an open way. We share the source code and apply an open source, OSI approved, license to it. You've probably already heard of cloud computing. Wherever we are in the world, much of our computing today happens in the cloud. Cloud computing allows remote computing or processing using a server, often through a third party. Remote processing is possible thanks to the internet. It allows us to access remote technology. Public cloud can be accessed via the internet by anyone who buys the service. Private cloud is, yes, just as you thought, dedicated to one organisation and not accessible to the public. Cloud allows sharing of technology to process and host apps, games, and other software tools like databases. We may share the servers these are hosted on with others, sometimes many others. This is done on servers in data centres that belong to cloud providers. Companies like AWS, Red Hat, IBM, Microsoft, Google, and OVH, as well as many smaller companies, provide cloud services for everyone. They have large data centres of servers, which they share with their customers. Much of the technology used in cloud computing is open source software. Cloud computing often mixes open source software with proprietary software, which is possible because point 9 of the OSD allows open source software to be used with any software. Cloud means we use only the server capacity we need when we need it. That makes servers more efficient. It also allows everyone to share the cost. Reducing the cost makes technology more accessible to all. So, cloud can help us to build resilient digital infrastructure in line with SDG 9. Infrastructure used to be things like roads and schools. Today, our infrastructure is not just those physical things, but also the internet and the cloud, which are used to provide us with services. But we always need to consider the environment and to improve energy efficiency and data centre energy efficiency. All the processing of our digital activities keeps data centres busy. They use and generate energy. In line with SDG 12, we ask the data centres and cloud companies to use sustainable consumption of our environment and energy. Environmental requirements and sustainability is very important. One of the most famous pieces of open source software that make the cloud work is Kubernetes. It was created by Google, who then made it open source and shared it as open source software for everyone to use. Kubernetes allows apps to run in an isolated environment, or container on a server, a remote server in the cloud. Containers need to be managed. That's called container orchestration. Kubernetes' name comes from the Greek word for a ship's captain, which makes sense as it orchestrates or directs the apps. It is often used with another piece of open source software called Docker, which helps us run the applications in a container. Of course, Kubernetes, like the other open source software we've explored, sits in a foundation, the Cloud Native Foundation, or CNCF. CNCF is part of our old friend, the Linux Foundation. The LF also looks after many other open source software projects, as well as Linux. Kubernetes has a really fun mascot like Linux. Its mascot is Fippy the giraffe. Although you might think they're a little young, it's worth listening to or reading the CNCF books, Fippy and Friends, which explain Kubernetes and Docker in more detail. We shared them with you in the e-zine, and you can learn a lot more detail about cloud technology using them. When people started to imagine developing remote IT infrastructure, they drew it as a fluffy cloud in diagrams. It was unimaginable to them just a few years ago. That's where the cloud name comes from. We first called it cloud computing, and today we just talk about cloud. This has evolved from that unimaginable fluffy cloud of a few years ago to today, where we have technology like containers managing the cloud. We were able to process on virtual machines as well as physical servers. This is largely thanks to open source software. Virtual machines also help reduce the need for servers and hardware, which is good for the environment. So, cloud computing has nothing to do with rain after all, but was just a way of representing the technology being imagined. I was looking forward to seeing a big rain cloud and maybe a thunderstorm. I like clouds. Nimbus, cumulus, stratus, all Greek to me. Bit like Kubernetes. Actually, cloud types are Latin-based names, but Kubernetes is Greek. In this lesson, you will learn that open source software can be used with any software, what cloud computing is, that open source software including Kubernetes, Docker and CNCF are important in cloud. Use abstraction when creating a cloud swiping game. All this talk about clouds has given me an idea for a new game using clouds. Let's try to find clouds scattered around a 360 degrees circle. Oh, hang on. That reminds me of something. We could use the compass we made in lesson 7. Then, when we find a cloud, we can ask the microbit to remove it. As it removes the cloud, it will reveal either a rainbow, yay, or a thunderstorm, boo. So that's what's under the cloud, a rainbow or a storm. If we get a rainbow, we gain a point, but if we find a thunderstorm, we lose a point. We can keep score, and once we've got 3 points, we've won and the game ends. I like it. And we can reuse code we have already made in lesson 7. That's exactly what an open source developer would do. Reuse or recycle code and build on top of it. Can be other people's code or our own. In MakeCode, navigate to your projects page and select your lesson 7 code. Click the duplicate button in the top right corner. Name your new project and open it up. Start off by deleting the score function and then the onShake block. We won't need them, so it's good to free up some screen space. We want some of the code in our new forever block, but we're going to move it around, delete some and move some into functions. That leads us to abstraction. That's a new coding concept for us. Abstraction is hiding details of a problem if the details aren't needed at that point in time. This allows us to concentrate on those details which are needed at that time. Using abstraction, we can create a more general view of the problem, which can make it easier to understand and solve. If we were to describe an umbrella to someone who had never seen one before, instead of jumping into details, we could just draw a simple outline of an umbrella so they understand vaguely what an umbrella looks like. This makes concepts much easier to understand. In this case, by using functions, we are using abstraction. We hide details that aren't needed now anyway. We do that in functions, so we just refer to the functions for now. I guess that's a bit like an app sitting in a container in the cloud, waiting until it's needed. Using abstraction means we can focus on the main purpose of the code, instead of getting bogged down in the details. Let's start our game by generating a new cloud. We want to generate a random position somewhere around the circle. Create a new function called newCloud. You see the line in the newGame function, set target equal to pick random from 0 to 360. Copy that into the newCloud function and then return the target variable. While we're here, we might as well take all we can from the newGame function. Copy across the first 2 lines, the ones that deal with the found and attempts variables, and move them into the onStart block. Right, that's all we need from the newGame function, so we can now delete it. Let's get into simplifying the forever block. Create a new function called swiping. It should take 2 inputs, our old friend, a Boolean variable called cloudFound, and a number called target. This runs when we're searching around the circle to find a cloud and deals with what happens when we find one. Is there any code in the forever block you think might be useful here? Finding the number of degrees we're away from the target is pretty handy, don't you think? First, set a new variable found equal to the input parameter, cloud found, and create a while loop that runs while found is equal to false. Move the code lines from the forever block, starting with degrees set to compass heading and ending with pause 500 ms into the while loop. Finally, make the following changes. Delete the else clause, remove the pause block at the end, remove the start melody block from inside the if clause, and change the condition of the if clause from 30 to 10. That's a lot of changes, but if you do them correctly, your swiping function should now look like this. Isn't it great that we're able to save writing all those lines by recycling code? In fact, to finish off our function, we only need to add one more line. But we've got to save that until a bit later, when we've created our other functions. When we find a cloud, we swipe it away by shaking the microbit. We can use another function to deal with this. Let's create that function now. It's going to be called swipe cloud and doesn't take any inputs. Inside, we'll have while loop, which keeps playing the baddie melody. That tells us we've found a cloud and goes away when we shake the microbit hard enough to swipe the cloud away, using the condition while acceleration in the x direction is less than 500. Once we've shaken the microbit, we'll be outside the while loop. Like the previous function, we also have one more line. But guess what? This also depends on another function. I can't decide whether this is frustrating or funny. Thank goodness, there's just one more function. When we swipe away our cloud, we need to determine whether we found a rainbow or a thundercloud. Then we return either a 1 or a -1, respectively. We do this using a simple if-else statement. Create our last function, which is called rainbow or thunder. Use the pick random true or false block to determine whether we found a rainbow or a thundercloud. This is the condition for our if clause. Our if clause will be if we found a rainbow and play the goody tune, an ascending melody of notes, and return 1. Our else clause will be if we've found a thundercloud. We play the baddie melody and return -1. All right, we've created all our functions. We can add our last lines of code to the swiping function and the swipe cloud function. In the swipe cloud function, we want to add a return block, which returns the results of calling the rainbow or thunder function. We're almost done. Our final piece of the puzzle is to modify the forever block. Delete the repeat 3 times loop and its contents and replace it with a while loop, which loops while the attempts variable is less than 3. This means that once we've got a score of 3, we've won the game. Congratulations to us. Look at all the lovely abstraction we're using. Our functions have been used to hide all the tricky detail away, and this lets us explain what the main program does, just using the forever block. Inside the while loop, we'll create a new cloud, stored in a variable called target, using the create cloud function we made earlier. This means that every time we go around the loop, the cloud is generated in a new position. We also want to update our attempts variable, which is a measure of our score. It goes up if we find a rainbow, and decreases if we find a thundercloud. Change attempts by the result of calling the swiping function. The first argument should be false, and the second argument should be our target variable. Finally, after our while loop, but inside our if statement, we want to play the power-up melody to let us know we've won and the game is finished. I just wish it was as easy for me to wipe away this terrible weather. I'd love some sunshine and a 99. Hey ho. So, finally, flash the code to your microbit and have fun playing around, finding clouds, shaking the microbit to clear them, and seeing whether you create a rainbow or a thundercloud underneath. Let's hope that you see rainbows. In this lesson, you have learned that open source software can be used with any software, what cloud computing is, that open source software, including Kubernetes, Docker and CNCF, are important in cloud. Use abstraction when creating a cloud swiping game. As well as Fippy and friends, we've talked to a few of our open source friends in the e-zines. You will see Liz Rice, Alexis Richardson, Cheryl Hung and Justin Cormack talking about cloud, Kubernetes and Docker. Oh, and of course, Matt Barker, our entrepreneur in residence too. Lots of people working in cloud and specialising in open source software. See you next time for our final lesson in this course.